Assalamualaikum to all and to the lecturers. Today we are from Group 7 will present about gears. Actually, what is gears? Gear is a rotating machine part having cut teeth or in the case of a cogwheel, inserted teeth called cogs which mesh with another tooth part to transmit torque. Then we will talk about the application of gears. First one, it is used for toys and small mechanisms because it is small, low load and low cost. Next, gears are used in appliance gears because it is long life, low noise and cost, low to moderate load. Third, the gears are used for power transmission, which is long life, high load and speed. Then, the gears are used in aerospace gears because it lightweight, moderate to high load. And finally, uh, the gears used to control gears because it long life, low noise, and precision gears. Next, we will talk about the types of gears. The first one, spur gears. Tooth profile is parallel to the axis of rotation. Transmit motion between parallel shafts. Second, helical gears. Teeth are inclined to the axis of rotation. The angle provides more gradual engagement of the teeth during meshing, transmit motion between parallel shafts. Then we have bevel gears, which is the teeth are formed on a conical surface used to transfer motion between non-parallel and intersecting shafts.
Okay, we move to the next type of gears. The first one is worm gear sets. It consists of a helical gear and a power screw. It looks like worm, used to transfer motion between non-parallel and non-intersecting shafts. Next, rack and pinion sets. A special case of spur gear having an infinitely large diameter. The teeth are laid flat. This is the diagram of type of gears. We can see spur gear, helical gear, spiral bevel gear, spur bevel gears, spiral bevel gears, rack and pinion gears, worm gears, planet pinion carrier and shaft, hypod gears. Next, the nomenclature of spur gear teeth. We can calculate the backlash by using this formula. The tooth spacing minus by tooth thickness, and we can get the backlash. The useful relations. To calculate the diameter pitch teeth per inch, we can use this formula P equal to N over D, which is P is diametral pitch teeth per inch, N is number of teeth, and D is pitch diameter.
Okay, let us continue with kinematic of gear trains. With conventional gear trains, we can calculate the speed ratio by the formula mv equal to negative n2 over n3 times by negative n4 over n5, which is equal w5 over w2. This is output over input. Output is product of number of teeth on driver gears, and input is product of number of teeth on driven gears. mv equal to E, which is equal to train value. Planetary of epicelic gears, planetary or well known as epicelic gears. This is gears whose center can move. It used to achieve large speed reductions in compact space. It can achieve different reduction ratios by holding different combination of gear space, which is not all gears can do this. And lastly, it used in automatic transmissions of car, which are always called as gearbox. And next, a little bit components of planetary gear. In planetary gear, we have planet, we have carrier, we have input shaft. Next, we have sun gear, and lastly, we have ring gear. Let's talk about gears manufacturing. Gears can be manufactured by a variety of processes, including casting, forging, extrusion, powder metallurgy, and blanking. As a general rule, however, machining is applied to achieve the final dimensions, shape, and surface finish in the gear. The initial operations that produce a semi-finishing part ready for gear machining as preferred to as blanking operation. The starting product in gear machining is called a gear blank. I think that's all from us. Thank you.
Thank you.